Notes 48. Is the whole number a base or not a base? So x squared times x cubed means x times x times x times x times x times x, which simplifies to x to the fifth. The x's are bases, so you can keep the base the same and add the exponents. 3x squared times 3x cubed means 3 times x times another 3 times x times x times x. So 3 times 3 is 9. And then you can add the x's and get x to the fifth. So that's 9x to the fifth. These 3's are coefficients, so you multiply them and add the exponents of the x's. On the next one, we have 3 squared times 3 cubed. And it is not 9 to the fifth power. It means 3 times 3 times 3 times 3 times 3 times 3, which simplifies 3 to the fifth, or 243. The 3's here are bases, so you keep the base the same and add the exponents. So let's take a look at working some of these problems out here as an example. So we have 3x to the fifth divided by 3x to the fifth, and I've already written it out in expanded form. So the 3's can cancel out here. We have a pair of x's, another pair, and another pair. So we are left with 2 x's in the numerator. So simplified version would just be x squared. Number 2, we have 3 squared divided by 3 to the fifth. So we have 2 3's on top, 5 3's on the bottom. We can cancel out a pair. So since everything cancels out in the numerator, that will be 1 over, and we have 3 cubed left in the denominator. Now, if we wanted to reduce that just a little bit more, 3 cubed is actually 27. So this would be 1 over 27. As a shortcut, you could also subtract 5 minus 2 and get 3. And so that's the 3 left over in the bottom. Number 3, we have 8a to the fifth divided by 8a to the sixth. So again, I have this out in expanded form. So I can cancel out the 8's, and then I have 1, 2, 3, 4, 5 pair of a's canceled out. So this would give me an answer of 1 over a. And if I did this without expanded form, you could cancel out the 8's, and then you could subtract the 6 minus 5. That would give you 1. The larger number exponent is in the bottom, so that's where your leftover a's would be. Number 4, we have 2 to the seventh divided by 2 cubed. So again, I have this in expanded form, so you can cancel out 3 pair of 2's. So that leaves me with 2 times 2 times 2 times 2. So 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. And if we did this without the expanded form, you could subtract 7 minus 3 and get 4. So basically that would look like 2 to the fourth power, which is what we ended up with. Number 5, we have 5 cubed times 5 to the fifth. So we're just going to multiply all that out, and I believe, let's see if I don't know, that's 25. That would be 390,625. All right, number 6, we have 5x to the fourth times 2x cubed. So we would take the 5 times the 2 and get 10. And then we have 1, 2, 3, 4, 5, 6, 7 x's. So that would be x raised to the 7th power. If we did it without the expanded form, we have our 5 times 2 is 10. And then we can add 4 plus 3 and get 7. Number 7, we have 4 squared quantity raised to the 3rd power. So that's basically 4 squared times 4 squared times 4 squared, which gives us 6 4's, which is 4096. Now then, as a shortcut, if you didn't want to write an expanded form, you could multiply these. So 2 times 3 gives you 6, and then you could just put that in your calculator if you like. Number 8, we have 4x squared quantity cubed. So that's 3 sets of 4x squared. So you can multiply the 4's together, and then you have 6 x's. If you did this without using the expanded form, you just have to take that 4 and cube it. So 4 cubed is 64. And then power to power, you multiply those powers. So 2 times 3 gives you 6. So this would be x raised to the 6th power. All right, let's look over on the back side. Simplifying. When the base is a whole number, leave your answer in exponential form. So on number 1, we have 5 cubed times 5 to the 4th equals 5 to the 7th power. The 5s are the bases, so leave as an exponent. Number 2, 5x cubed times 5x to the 4th. The 5s are coefficients. So you see the difference between when they're bases versus when they're coefficients. So you're going to have 5 times 5 is 25 x, and you can add 3 plus 4 and get 7. Number 3, 3 times 3 is 9, 9 times 3 is 27. X to then, remember this is understood to be to the 1st power, so this would be x cubed. Number 9, the 9s are the bases, so leave as an exponent. So we're going to have a 9, and then 2 plus 3 is 5, plus 1 is 10. So that looks like a G. It's 9 raised to the 10th power. Number 5, 6 to the 5th divided by 6 squared. So 6 is your base, and then we can subtract. 6, 5 minus 2 is 3. Now some of these smaller ones, if we want to go ahead and simplify the 6 to the 3rd power, you could do that. Or you can just leave it as 6 cubed. So this is actually 216. All right, number 6. 16 and 4 you can reduce. So 4 divided by 4 is 1. 16 divided by 4 is 4. And then you're going to subtract the exponents of x's. So 5 minus 3 is 2, and the larger number's in the numerator. Number 7. This would be, you're going to take each term inside. So this would be 10 cubed, which is 10 times 10, well, 1 with 3 zeros. And then you can multiply 2 times 3, these exponents. So that would give you x to the 6th power. So 1000 x to the 6th power. Number 8, multiply 5 times 7 and get 35. Number 9, this would be 4 to the 15th. So when it's going to be a really big number, we'll just leave it in exponential form. Here, this would, you're going to take 2 to the 4. So 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. X to the 4th power. Number 11. 3x is a base, so it needs to be part of your answer. So let's take a look at the exponents. So we're going to go 3 minus 2 is 1. That 1 left over will be in the denominator. So it's going to look like this. 1 over 3x, because 3x is the base. Number 12, we have negative 2 is your coefficient. It's going to be raised to the 4th power. So negative 2 times negative 2 is 4. 4 times negative 2 is negative 8. Negative 8 times negative 2 is 16. X, and then we're going to multiply 4 times 4 and get 16y. And this y is understood to have a 1. So 1 times 4 gives you 4. Number 13, let's see, 4 is your base. 1/2 plus 3/2 is 4/2, which is 2. So that would actually give you 16. Number 14, again, 12s are your bases. So 1/3 plus 4/3 is 5/3. So it'd be 12 raised to the 5/3 power. Number 15, be careful. You can only add the powers if the bases are the same. So if the bases are different, see what it gives you when you put it into the calculator. So basically when you put it into the calculator, 8 raised to the 1/3 power is 2, and 4 raised to the 1/2 power also gives you 2. So 2 times 2 gives you a whole number of 4.